So the goal for the last page was to get the to graph the basics, and so now we're going to talk about, my dog can hear something, my sister's dog can hear something, talk about how amplitude and period will help. So let's go back to this stuff. If we have this constant factor A in here, it kind of acts as a scaling factor. A scaling factor. Oh, that's not focused. There we go. A scaling factor. A vertical stretch. Or if it's a smaller than 1, it's a shrink of the basic, and basic, when it's sine, the basic sine function. And this is kind of what we talked about here. I'll zoom in, maybe. Yep. Okay. So it's a scaling factor, a vertical stretch or shrink of the basic sine function. So then when that absolute value is bigger than 1, the sine curve is stretched. It's made taller. Or if it's the absolute value is less than 1, it's shrunk. And the result, so in other words, the graph is going to go up and down between negative A and A, instead of between negative 1 and 1 like the basic one we had. So then the absolute value of A is the amplitude. Of the function a sine of x. So here we have this example. If we had the graph of negative 0.5 sine of x, we can see, because there's the negative right there, it is a reflection because of that negative right there, in across the x-axis basically. And then there we go. So if it's a negative, it's a reflection. We could also see, because of the 0.5, that would be a shrink. And it would bounce up and down between 0.5 and negative 0.5. Okay. And then we're talking about B. So B has an important role more than other things, and B is actually kind of a very popular topic with trigonometry, where if we did parabolas, maybe it's not as often, we don't use it as often. So if B is a positive real number, the period a sine of x, sine of bx, and that thing, so it's kind of doing the same type of thing. The period, so the normal period is 2 pi, but if you have any number in front of the x, you divide it by b. So the basic one, that b is 1, and so that's why it's 2 pi. But then any other number is going to have it basically repeat the pattern faster. So rather than, because on our graphs that we had on the other page, it was kind of like, we would say, so sorry, bumpity bump. Okay, so this kind of is stretched out like this. But if the period, if we divided it by 2, then it would go up, down, back within pi, because half of the normal 2 pi would be pi. So it'd go up, down, up in pi instead. So that B makes it just basically wiggle back and forth faster. Okay. And then, so it's saying if B is in between 0 and 1, the period is greater, so it stretches it. So basically it takes that graph and it's like it pulls it out, stretching it. So like it's taking longer to get those things. Instead of shorter and faster, it makes it go slower. And then the 2 pi represents a horizontal stretching. It represents a horizontal stretching of the graph y equals a sine of x. When b is greater than 1, this thing is less than 2 pi and represents a horizontal shrinking because it kind of like compresses it. Of the graph y equals sine of x. So here's an example. Find the amplitude and the period of -4 cosine of 3x. So we know that that has to do with the amplitude and that 3 is the b part of the period. So we can say our amplitude would be 4. In fact, we can kind of say, yeah, the amplitude is -4 because that negative does come into play. Because we know that that would give it a reflection. And then, so instead of starting up, going down and back up, it would start down, go up and back down. And then the period, we take our 2 pi and divide it by that b, which is 3. So that means it's going to make one full rotation, or one, like it's going down, back up, and down in 2 pi thirds. So it's going to be faster. Instead of 2 pi thirds, it's going to be 3 times as fast. Okay, so then the big thing, there are the 5 key points. So we have intercepts, max, and mins of these graphs. So one period of these graphs will have 5 key points. So it's the same thing again. So I'm just going to draw my quick sketch of this. And if you can't, and I'm sure that you can't see it because you haven't graphed these before. So let me just use my expertise to help enlighten you. So we have 4, -4. And then our period, I just come over to the side of the graph and I'm just going to do 2 pi thirds. And then halfway between those, because I know it's supposed to do stuff at halfway between. So half of 2 pi thirds would be 2 pi thirds divided by 2. In other words, we can make that 2 pi thirds times by the 2 on the bottom because it's half of it, which is 2 pi sixths, which is just 1/3, like pi thirds. You may have seen that really easy. If we have 2 pi thirds, what's half of 2 pi thirds? Just pi thirds. And half of that is pi sixths. And halfway between those is going to be pi thirds plus pi sixths. Or if you want to look on your unit circle, you could. So pi thirds, so I'm going to do pi thirds plus pi sixths. And maybe you want to think about this in degrees, and it will help. So pi thirds I know is 60. Pi sixths is 30. 60 plus 30 is 90, and I know that 90 is the same thing as pi halves. So right here, this is pi halves. Okay, and then, so those are all my important points there. And now I'm just going to graph them because it helps me feel better about it. So I know from the other page that cosine starts normally up, but we have a negative, so it's going to start down here, and it's going to end down there. I'll use a different color for the sake of stuff. So it's going to start down and end in the same place down. And halfway between, it's going to reach the other side. And then it's going to cross there and cross there. So we have curvy this way, curvy here, curvy down, curvy down. So we want those 5 points. So our intercepts are at, so it's going to be our x, our angle, so pi 6, 0, and at pi halves, 0. And then, so those are our x-intercepts. So right, we would have 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Good. So we have our intercepts. Then we have our max. On this one is that point right there. So that point is at pi thirds, comma 4, because that's our y there. Our min, we have 2 of them. 1 right there and 1 right there. So our x there would be 0, negative 4, and then the other point right there, and 2 pi thirds, negative 4. So we have our 5 points, 1, 2, 3, 4, 5. Good.